Yeah, I can.
Very good. Thanks, Paris. Good morning and welcome to my presentation, How to Incorporate Big Data in Analysis Services Cubes. This morning I thought I would start with my introductions and then talk about the general concepts in terms of what's involved with making this all happen. After that, I thought the best way to solidify these concepts would be a demonstration on taking a look at the end result. After that, we'll take a look at the code underlying how this all happens, and we'll follow it up with questions and answers. Again, my name is Reed Carabush. I'm president of Decision Systems. I've been working in the field of multidimensional database and analytics for a number of years. I started off as a product manager for a computer software company, got into consulting many years ago, and have been focusing on helping organizations get better value out of their solutions. Our firm is based in Northbrook, Illinois. We've been in business since 1989, so we're approaching our 25th anniversary. We're Microsoft and IBM business partner, and we're also the business partner of a company called PolyVista. It's a software company that has a product also called PolyVista that I'll be demonstrating here to some extent today to help explain and show this solution. We specialize, again, in performance management and analytics. We mostly work with Fortune 2000 customers in a variety of industries. We recently completed a 7-year project working for the Major League Baseball Players Association, where their player agents use analytics to help them through the arbitration process, and I suppose get better salaries for the players. We've designed and implemented probably 50+ systems over the years. Our consultants are typically all expert level, many of them having MBA and CPA degrees. Our solutions are focused on budgeting, forecasting, planning, and analysis, and we cover a myriad of functional areas such as operations, marketing, etc. We get involved in both descriptive and predictive analytics, as well as text and data mining, which we'll be talking about here today. Finally, our services include application design and development, and the technologies we deal with are typically business intelligence, multidimensional databases, data marts, and warehouses. And we also do quite a bit of remote application support. So that's a little bit about myself and our firm. And without further ado, let's talk about the general concept. So I put down here, it's time to start thinking outside the cube. The reason I say this is because a lot of people, including myself, oftentimes get stuck in a rut developing traditional applications, and the question came on my mind a number of years ago as to how to start leveraging analytics, especially in combination with business intelligence and OLAP. So the thing that we're going to talk about here today is mostly the concept of text mining, but I also want to talk briefly about discovery, because discovery in many cases facilitates the ability for you to leverage the results of text mining. So we're going to take a look at that and show and demonstrate how that helps one to better understand the results that are yielded by this process. I want to talk a little bit about what is called the building blocks of knowledge. Perhaps some of you have seen this slide before. It got me actually started in analytics when I first saw this slide. If you take a look at quadrant or state 1, we call that you know what you know. That's generally the situation where you're supporting business as usual. It's typically oriented at management reporting or standard reporting. Many people develop static reports, and it's been around for many years. We then get into the state 2 area, which you could call the area of query and analysis, and that perhaps is the space that typically analysis services fits in. Generally, this area is an area where you kind of know the domain in which you want to ask the question, but you don't know the answer to the question. So you specifically run queries, do slice and dice to come up with your answer. So the left sides of the quadrants is what we've been dealing with for many years, and the question then becomes, what's going to happen after OLAP? Well, I took a look at this chart, and I realized that, in fact, it was analytics. If you take a look at state 3, which is you don't know what you know, that's the area that's perhaps called knowledge management, or it's where a company is really not communicating or making no knowledge available to those who need it. So far, most organizations really don't pursue knowledge management. It's really not as popular as perhaps it should be. But I think we're a ways away in terms of years before companies start focusing on this particular area, state 3. State 4, I think, is really more interesting, and it happens to be related to text analytics, at least for this demonstration. And that's the area of what we call you don't know what you don't know. It's really very interesting, but yet it's a precarious state, because in business, what you don't know can really hurt you. Being unaware of issues and opportunities could really adversely affect your company's performance. So the idea of basically being able to find information that you weren't aware of or you didn't consider looking at is a real opportunity, and that's something that we can leverage within analysis services and also apply it in combination with text analytics or big data analysis. So today I'm going to talk a little bit more about discovery and more specifically big data analysis and how that combines with discovery when using it within Microsoft Analysis Services. So the good news is that hopefully I think you'll perhaps get one of those aha moments when I share some of these concepts with you. The bad news is that, or maybe it's good news, there's not a huge amount of complexity to this code for the most part. I think it's really just a unique twist on how to use analysis services to incorporate big data in your work, but I'll let you guys and gals be the judge. So the way I thought to best describe this concept was to take you through a demonstration first. And the demonstration is going to be a sample that was put together using the National Highway Transportation Safety Board database of automotive complaints. Essentially, this is a publicly accessible database that individuals can go to and write about issues with their vehicles. They've been doing that for quite some time. The data that we're going to look at is after 2003, pretty much to the current period, and we'll use this as an example to understand how big data and text analytics fits within analysis services. After that, we'll take a look at some of the detailed code. The code and the technologies that are used here primarily are Microsoft Analysis Services. We'll be using Systems Integration Services and Microsoft SQL. I've been using 2008 R2, so this does not reflect the most recent version of this technology, but pretty much it all works the same within that environment. I'll also be using one of the PolyVista technologies called the PolyVista Client to help demonstrate discovery and more specifically text analytics, and we'll talk about that in detail. One thing I wanted to point out here is that I'm assuming that most of you are already familiar with how to build cubes, how to use SQL Server, and systems integration services. So we're going to be skipping all the basics here. Frankly, we don't have time to get involved in that. And in order to implement a solution like this, you actually have to touch on many different technologies. Not only do you have to be familiar with SQL Server, you have to be able to develop cubes and analysis services, you have to be able to automate the solution and systems integration services, and then finally, you have to have some familiarity with text analytics and text mining. So there's a lot that's going to be on your plate when doing this, and hopefully you have the requisite knowledge to do something like this, or you know the right people to contact. So I guess without further ado, I'll start with the demonstration, and then we'll move into the solution and the code. Okay, so essentially what we're looking at here is the end result. I have an interface called PolyVista Discovery Client, but you'll see here that I have in the background Analysis Services 2008, and you see my cube is in the browser. So PolyVista is simply a client to Analysis Services, and I also have bids running in the background here. All right, so let's discuss briefly the dimensions of our cube. First of all, we have our measures, and for the most part, we're looking at the complaints count, meaning the number of complaints that individuals have submitted regarding their vehicles. That will be the primary measure we're looking at. I do also have some computed measures. We also have as dimensions the age of the vehicle is one dimension. I have the dates of the complaint. And for the text analytics, which we'll get into a little bit more detail later, I have complaint text and what's called the complaint text raw. Finally, we have the components of the vehicles that are grouped in a hierarchical fashion, of course, as well as locations of where the complaints took place by state and city, the makes and the models of the vehicles, as well as the makes and the detailed models, finally the mileage of all the vehicles involved and the year they were manufactured. All right, so we'll come back to the text dimensions, but notice they are in fact dimensions in our cube. All right, so let's take a look at perhaps the discovery process, and we'll show you that by taking a look at the PolyVista client. In general, the discovery, I think you could say, is the process of using an algorithm, mathematical algorithm, specifically in this case it's, I believe, a chi-square analysis, to automatically sift through the cube. In this case, I think you could consider it automated slicing and dicing, and we'll do so by using a wizard-based approach, bringing up the various algorithms that are available to us in PolyVista. So I have discovery selected, but you'll notice I have a number of other algorithms that we could run within this client 2 analysis services. Notice at the bottom we also have text mining, which we'll be talking about a little later. So to run a discovery, basically I'm saying, okay, analysis services, show me what's interesting. This is kind of the antithesis of typical slicing and dicing, which you start usually at doing a top-down slice and dice and drill down analysis of perhaps the variances. But in this case, we're going to turn the tables. We're going to ask the system, okay, what do we want to analyze? And in this case, we want to look at the complaints count that's out there. The next thing we're going to take a look at is, well, what parts of the cube do we want to look at? We can look at, maybe to start off, we'll look at all makes and models and all components of vehicles. That's about close to 800,000 cells. So rather than spending the next few hours slicing and dicing, I'm going to start PolyVista in a manual mode to process and analyze the cube results for those 2 dimensions. Well, it's finished, and notice it displays the results in the form of a histogram, where the positive anomalies are ranked in green, followed by the negative anomalies in red. All right, so let's take a look at the very top item. What did it come up with? Vehicle speed control, Toyota. Well, I'm sure you all heard about the runaway Toyota problem, what was the sticking gas pedal and all. Well, that ranked number 1, and we didn't have to leverage all this technology to find this out. We probably could have just read the newspaper from a couple of years ago. But clearly when you're doing discovery, it's not the items at the very top or the very bottom of the list that you want to find out about, because you probably already know about them should you be doing your job or reading the newspaper. What's more difficult to find out is the issues in between. Essentially, things you don't know about that perhaps the system is suggesting you do take a look at. So what I'm going to do here is I'm going to open up another grid, a spreadsheet, and notice that in total in this database we have about 365,000 records. So that's the size of our data that we downloaded and are analyzing. So let's take a look at maybe the second item, digital instrument panel Chevrolet. There's definitely something going on here because it was the second highest scored anomaly. I'm going to drag the results into the grid, and we see that there was a total of 2,426 complaints regarding the digital instrument panel Chevrolet. Now, traditionally, one at this point using analysis services would maybe decide to do some slicing and dicing. Maybe what I'll do is I'll keep this cell and at this point I could start doing some slicing and dicing. The typical analyst might take a look at how about the age of the vehicle. Okay, so we see here that well, 3, 4, and 5 years old make up the majority. If we wanted to, we could look at a Pareto analysis to show that 3, 4, and 5 years old are about 71% of the vehicles. But to continue on, you know, maybe the next thing the person would do is maybe take a look at the location. So we'll drag location into this. And here we see that, well, we have quite a bit of peaks in Texas. I think that maybe if we select the ages we narrow it down to 3, 4, and 5. I think you'll get the idea that, you know, that's pretty much where the problems are occurring in Texas regarding 3, 4, and 5-year-old vehicles. Now, at this point in time, this is where, you know, traditional OLAP analysis might end. I think that by using discovery, we're able to more zero in on the issues at hand. But typically, when you do OLAP and this type of analysis, what you're able to find out is what's going on, meaning what are the numbers, what are the anomalies, etc. In the past, we really never were able to directly figure out the why, meaning why things were happening, okay? So I think that's one opportunity where text analytics comes in, is we have the ability to start taking a look at the why. And we do that by leveraging the unstructured data, in this case, in the records that have come in with the data. So I'm going to show you the end result first, and then we'll take a look at the code in terms of how we came about it. But what I did was, prior to building this cube, I created a dimension in analysis services that's called complaint text. And here you see it here. Basically, it's a hierarchical dimension. And I like to call it a topic map, because what this represents are the topics and the subtopics that were, let's say, extracted and massaged out of the unstructured data from within each record that was supplied to us. And we processed it using a text mining algorithm in order to develop the end result, which was the parent-child table, and thus the dimension that we're looking at. So if you wanted to, you could drill down, and maybe you could drill down on engine light, and you would see subtopics regarding the engine light that were recorded. Okay, so now how do we use this information? Well, the idea here then is that what I'll do now is we could do traditional slicing and dicing, but this is a little faster. So I'm going to run another discovery, again on the complaints, but this time I'm going to select the complaint text. Notice in total now we have about 25 million numbers that we're going to look through. And again, let's run the system to check out the anomalies. Now, it just completed the results, and maybe to continue on our story regarding the issue with the Chevrolet digital instrument panel, let's go down the list and look for that particular anomaly, which is right here. Notice that it says complaint text, speedometer, instrument gauge, digital cluster speed for the Chevrolet. Okay, so what is that telling us? And again, I'll drag it here. We see 3,924 complaints. Well, what that's telling us is that now not only do we know what the issue is, meaning it's a problem with the Chevrolet digital instrument panel, but because we created a dimension of the topics within the unstructured data, and because they're now all indexed against the other dimensions, we're able to determine that the reason why it was happening was because our complainers, or I guess our customers you might call them, were telling us that the issue was with the speedometer within the instrument gauge digital cluster speed control. So that's really quite interesting, at least to me, because when I used to be a financial analyst, after doing financial analyst, you look at the numbers, then you had to figure out why. Well, now we can leverage the unstructured data and, in essence, whether it comes from a call center, a public database, or even social networking, we can combine that with our structured data and get additional insights into what's going on with our information. In this case, why is it happening? Now what I can do at this point is I'll right-click and I'll do a drill through. And what this does is it brings up the records from SQL Server, and if you look closely, all the records will have mention of the speedometer within the Chevrolet vehicles. Now in this case, all of our data is sitting within SQL Server. Doing a solution like this is also possible, perhaps if your data is sitting in Hadoop. I'm really not prepared to address that in this presentation, but that is possible as well. Okay, so hopefully this gives you an idea of how we've leveraged the unstructured data. And frankly, I think that as important as the topic map is to identify what your key issues are, putting it in context with your structured data, I think is almost as important. And that's what we've done by bringing it in with analysis services. So rather than trust a word cloud or a survey, if you have the ability to bring the text in combination with the structured data, you really start to leverage what's going on. Okay, so at this point what I'm going to do now is I'm going to switch over to the actual code, and we'll take a look at how we put this together. So I have another environment running here. So what we're looking at is the SSIS process, in part, that we use to build this, along with the SQL Server database called CARS Complaints that was used as part of this solution. All right, so I'll go through some of the basics. Unfortunately, we don't have a lot of time to dive deeply into each, but I think you'll see this is pretty straightforward, perhaps with the exception of one or two processes here. So we'll take you quickly through it. We'll start with the SSIS task, where basically we're simply deleting our existing data, and at that point we hand it off to download all of the data from the publicly available database. It comes in as a zip file, so we have another process that unzips it. From there, what we do is we basically, in order to start afresh, we're dropping the table and re-adding it. You certainly don't have to do that, but it was done like this, I suppose, for demonstration or expediency purposes. And at that point, our data is sitting in this table called flat_CMPL. So you can see the fields, they're all text, they haven't been converted, whatever. At that point, we load the data into that table, and again it will contain the unstructured data as well as these files. We're going to also create another table called comp name. Again, here we drop it and re-add it. Again, nothing spectacular going on here. And then we will load that table and do a couple of updates in order to pull in a few of these fields. Again, no magic going on there. At this point, we rebuild the fact table, and Notice it calls on a view, Carfax view. We'll take a look at that. Again, this is pretty straightforward. It does some data cleansing, I suppose you could call it. There's a few computations here. Again, it's mostly for formatting purposes. We convert some of the text to numerics, some of the dates, etc. Again, nothing out of the ordinary. And we bring in the additional fields we're interested in order to build our cube and load our structure. So again, this whole process is really based upon the ability to incorporate unstructured data, perhaps in existing standard cubes. Because so far, I haven't really done anything out of the ordinary other than I plan to actually use that text field that most people, I suppose, typically ignore or throw away. So let's take a look at how we actually leverage that particular field right now. So we do this process through a built-in program that comes with PolyVista called the text mining algorithm. I'm going to talk about how it works and show you what's involved. But basically, in addition to running it interactively through the user interface, we can also call it programmatically. And I can define various settings here that allows me to do the text analytics. But before I start going through these menus, I'm going to give you a little bit background on the process of text mining, at least as it relates to this particular process. First of all, there's two different basic approaches to text mining. There's what's called linguistic and statistical. Those two approaches have been available for quite some time. The methods that I'm using here are called statistical text analytics. So it's based upon a different technology. Primarily it uses clustering algorithms. So let's talk about really what's involved. First of all, there's really three aspects to the text mining. There's the process of what's called clustering, which is really the first process that involves the creation of hierarchical text clusters from the data fields, or in this case the free-form text that came from the automotive complaints. The second step is the process that's involving including the integration of these clusters in the multidimensional database, which we've already seen, and then finally analyzing them. So at this point we're going to talk about the text clustering process. And as you saw, this data came right from our SQL Server database. Essentially, the data is processed to create what's called a keyword frequency distribution, taking into account stemming, things like synonyms and stop words. That's actually our next screen here, where we identify their synonyms, stop words, etc. So what am I talking about here? Well, in order to do text analytics, you have to do what's called text integration, which is really the process of cleansing and structuring, let's say, the parameters for the text analytics engine. In our solution, which uses a more of a statistical approach, we need to define things like stop words. So, for example, as you can imagine, there were probably a lot of four-letter words when people were complaining about their car. Well, it's your responsibility as part of the integration approach to add the stop words. And there are standard templates that you can use to incorporate stop words. And these are words that you really don't want the text mining engine to consider. Things like because, or but, or both, or anyone. They're really not that descriptive. So we want it to ignore these types of words. Other examples might be synonyms. Synonyms, for example, some people might use the term ABS. Well, that of course stands for anti-lock brakes. So every time the system sees the ABS acronym, it will convert it to anti-lock brakes and use that in the clustering algorithm, because it does look at the frequency of words that are used and uses that to build the cluster. All right? Now, in this example, we actually don't use concepts and includes, which is another capability, and I'll actually ignore that for now. But understand that for every application you do that uses a different general unstructured data source, you'll have to go through the process of text integration. Generally, that process involves interactively processing the text and then cleansing it or modifying it by adding these additional stop words and synonyms, as well as adding some of the tuning parameters here. Now, we're looking at the end result, which is actually processed in the final form, but you can use a client interface for this kind of approach. Generally, on the average, I would say for any new data source, it might take about, let's say, 8 hours to do the text integration, because it's quite an interactive approach. Once you've got that worked down, you would then proceed through, and you can identify things like your minimum word length, your maximum word length, perhaps any kind of sampling involved, the nature of the stemming you use. And then you can also choose the type of vector space, any weighting schemes you might want to choose, etc. And then you can also reduce the data samples if you want. Finally, we choose our algorithm. We're picking the hierarchical k-means. That algorithm is typically the fastest and can process lots of data. PolyVista actually has a patent-pending parallel processing method that can handle millions or hundreds of millions of records. The actual amount of computing power that this takes is a little bit substantial, but after the one-time 8 to 10 hours of text integration, you could run through this text in a mere matter of, I'll say, minutes, depending upon its source. So we'll go with the means, and at this point we can define the scope of the hierarchy, meaning its width and depth, and finally we can maybe print any results that are available. So at this point, I guess I want to show you one other thing here. We can also identify the input source and the output source of our data. In this case, it's pulling the data from the fact table, and the output is putting the data into cars_brief_dat. So that's the table that the process would actually go through. So we'll take a look at maybe the results of that table. I think I have it here somewhere. Well, let's just you see the end result is nothing other than a parent-child table that identifies the parent key, the member key, and then the actual ID of the record. So the idea here is, from this information, We then use it to process our text dimension, and at that point we process the cube and we're ready to go. So really, I suppose the magic happens in the text mining engine, where we actually build the topic map and massage it to the structure we want. Now, what's interesting is that when we built our text mining dimension, I actually hid the frequency of the members, meaning the number of times or occurrences they happen, primarily because we're interested more in this case of doing discovery. However, if you expose the number of times the complaints show up, you can actually use that to assess perhaps individual product quality issues. For example, maybe you have a hard disk drive company and the drive is failing. By exposing the number of occurrences regarding the keyword topics, you can start to better understand what's going on. And we also can apply it against a different algorithm that enables us to look for trends, meaning, well, last week the drives were failing. This week the packaging seems to be incorrect. So you can start looking for trends in the unstructured data as well. I suppose that kind of sums up the detail. Why don't we take a look at the fact table here. You can see it's pretty standard. I do have the field for a brief description of the text as well as the complete unstructured data. The reason we have that is in addition to be able to do text analytics against the topic map, we also have the ability, if you want to do free-form search of certain keywords within the text that came into our data. So that's another reason for storing that information. And that's what the complaint text raw dimension is used for. So I think that kind of summarizes what I tried to convey regarding how to incorporate text in Analysis Services Cube. As you see, we really don't load the actual text, but simply create a dimension based upon creating a topic map, and then be able to relate that to the unstructured data through the relational drill through. Hopefully this was enlightening for you, and please feel free to ask any questions if there are so. I suppose, Paris, you can open the call to questions if there are any.
Sure. So there are a couple of questions in the CAT questions tab. I'm just going to say them so you can answer it.
Sure.
So here's number one. What text algorithm have you used to get complaint text dimension out of unstructured data?
Can you say that one more time?
Sure. What text algorithm have you used to get the complaint text dimension out of unstructured data?
I see. Well, I think I answered that. In this case, we use the k-means algorithm for clustering. And while I use the product PolyVista to do this, this algorithm may be available via open source. I know Microsoft does do clustering analysis in their analysis services data mining solution. However, I don't think it addresses text analytics. I could be wrong.
The questions, so there are a couple of questions around slides. I just want to mention that if you go to our site, bavc.sqlpass.org, and if you go to the meetings archives section, after the meeting you'll find all the material that's shared with you. So you'll find the slides, you'll find the slides that I talked through, and you'll also find the recording. Give us about 24 hours and it should be up on that site. So slides will be available for you to download. One of the viewers asked, what about the code, package, DDL, etc.? Would that be shared?
Again, can you repeat the question?
One of the attendee wants to know if the code, the SSIS package, I think that you showed, would that be something that you'll be sharing?
Which code are you referring to?
I think it's just referring to the package. I think SSIS package and the queries that you might have shown.
Oh, well, I mean, most of the code, as you saw, was embedded within the SSIS package. I tried to show that, but again, you know, I have to say that there really wasn't any uniqueness of the code here. I mean, you can embed text analytics in any analysis services cube you have, simply if you have the ability to create the topic map dimension. So while if you're interested and you want samples of the code that I use, I'd be happy to send that to you. Feel free to send me an email. I'd be happy to provide it to you. But again, it's nothing special. If you want to try this out in your own environment, I suppose that could be useful for someone.
Okay. Other question: can we use built-in Microsoft text mining algorithms instead of Polyvista's algorithm, since we would not have access to Polyvista?
Well, yeah, that's a good question. I mean, we can, if you're interested, we certainly can make Polyvista available to you. I can't tell you if products like R or open source analytic solutions have the k-means clustering algorithm. I just don't know the answer to that. But I did, in fact, I have used Microsoft's data mining clustering technology, but in that case, I believe I was only able to leverage the data that was stored within dimension members and attributes, and I don't think it has the ability to use text in that manner. So you certainly could try it, and I'd love to know the answer, but I don't personally think that's possible. But I could be wrong.
Okay. Just a few more questions. Do you want me to go on?
Sure.
Okay. So on the slide, the building blocks of knowledge, you talked about ways to know answers. Is data science, quantitative or qualitative, the only way to know information in business, or are there other sources?
Can you repeat that one more time? I'm not sure I understood the question.
Sure. So on the slide, the building blocks of knowledge,
right,
we talked about ways to know answers. So is data science the only way to know information in business, or are there other sources?
Are there other sources other than business? Was that the question?
I think, are there any other sources or techniques other than data science that you could use to know information in business?
Oh, well, yeah, definitely. I mean, in this case, this domain is really what we're really talking about is how, I'll call it decision support, or how people analyze data and use information. I imagine there's other sources, but in particular, the reason why I showed this slide is because I think that a lot of people in the market in general has difficulty putting together the concept of standard reporting and analysis into the area of analytics, or in this case, discovery. People talk about predictive analytics, etc., but they really don't know how it interrelates, how the two tie together. And hopefully my demonstrations, at least as it relates to text analytics, showed how you can incorporate this unstructured data in combination with the structure to get more value out of it. And when we look at these building blocks of knowledge, we see how they're basically related based upon the way in which you do things and how you do it. So, I mean, unfortunately, I never got my PhD in mathematics or information science, so I'm not sure I can truly address their question, but I think this is pretty comprehensive, as at least it relates to decision support.
Perfect. Other question. Is there a factor analysis option for clustering in PolyVista?
What was that word? I'm sorry.
Is factor analysis. Is there a factor analysis option for clustering in PolyVista?
Oh, I don't really know. There's a number of algorithms there. That one doesn't ring a bell, but if someone wants to send me an email with that question, I certainly can get back to them.
Okay. So one more question. You mentioned that the text mining is dependent on keyword frequency distribution and stop words. Is this technology dependent on SQL Server full text search or the recently announced, as of 2012, the semantic search?
I'm sorry, I didn't hear the last part of the question.
Sure. So we're just going to repeat the entire question one more time. So you mentioned that text mining is dependent on keyword frequency distribution and stop words. Is this technology dependent on SQL Server full text search or the recently announced semantic search?
I heard the semantic words. The answer is no. And I didn't hear the first technology that was mentioned, but everything that I showed you here was actually done under 2008 R2. So I suppose that answers that question.
Okay. So the two technologies that are in the question were SQL Server full text search versus the semantic search.
Right.
Okay. So there's a repeat question. Can you do this with third-party package? Could SSIS do this alone? I think you already answered that. Yeah, there's one more. You use PolyVista browser to analyze the data. Can you use Excel or some other tool to analyze the data?
Oh, absolutely. I think Excel is the most popular interface for analysis services. I certainly could have done slicing and dicing in Excel in order to do the same thing. The reason I used PolyVista was that it enabled me to do automated slicing and dicing, or in this case discovery, to look for the anomalies, which is, I think, key towards leveraging the unstructured data. But whether or not you bring your data in at the lowest level, or if it's a product at a brand level, you still could use Excel to look at the unstructured topics based upon doing manual slicing and dicing within that interface. I simply showed you the PolyVista interface because of the fact that it was able to do the automated discovery and found the significant anomalies without manual slicing and dicing.
Okay. There's a couple of questions around where can we find the videos. Just want to quickly point out that will be on our YouTube channel. Our username is PAST, BAVC, or you can just search for PAST Business Analytics Virtual Chapter YouTube channel. You'll be able to find it. Also feel free to email us if you have any questions. I think Reed, that's about it for the questions. Do you have any closing comments for the audience?
No, just hopefully this information was informative to you. I've been working in this field for quite some time, and I felt that this was kind of a unique solution that allows one to leverage analysis services, and hopefully you can start incorporating this type of technology within your analysis cubes as well. Thanks very much for your participation.
Yeah, thank you so much everyone for attending, and thank you Reed for presenting. There'll be a survey at the end of this presentation, so we'll encourage you to fill that out because it'll give us the feedback to improve the virtual chapter for you. Thanks again everyone. Have a great day.